Before starting, I'd like to share with you a story when I was a student at the School of Engineering. And when I started my programming course, nobody knew about these programs. And you would program in Windows, and any changes that you would make were left there, and that was it. Then a friend of mine recommended I should read a programming book called The Pragmatic Programmer, and there's a full chapter on version controls. And in this chapter, there was a quotation by this guy called George Santayana. And I thought it was very interesting because basically it gave a strong promotion to record in progress. It's not only recording something continuously and then lose traceability, but there is a strong value on it for recording and retaining all that information. So what's the relation with GeneXus server? Well, as he says, progress, far from consistent in change, depends on retentiveness. So in this version, we improved a lot, not only the simplicity and the way we can send data to the server and the way we store it, but on the basis of the stored data, we can interpret them in a richer manner and add value on those same data. Precisely, taking all this into account, we are progressing, we are doing it better in relation to previous versions. I'm going to divide my talk into three big topics. The first one has to do with improvements and changes in user interface and usability from the web console and leader development. Then I'm going to refer to the improvements on existing operations, servers, updates, the way we prepare objects when GeneXus asks for objects to the server, how you have improved that. And then lastly, the new capabilities, the new features in this new version, what problems are solved, why they were developed, and how this makes users' life easier. So if we start with the web console, when we look at the web console, we can see a full change. As you can see, those who are familiar with older versions, we wanted to have a console with modern style, modern feeling, making it attractive, but also this look and feel and usability had to be very good. So this is the login screen. There you have some links so that you can have access to online material and all the documentation in further detail and all the types of screens and so on. And also the URL of this server. Well, as I said, there was an important change. We changed the style, the typography, and also the navigation capability. Users can navigate naturally in a simple way in between the different screens. Here on the left, you can see the navigation tree of the new console. If you recall, it was quite different. And then the list of user controls, and something that we added in this console is the possibility of installing control processes through the web. Instead of going to the server, turn it off and install it, you can do it directly through the web. This image, this snapshot, is about the console, but it's the object in the web panel. And what I would like to highlight here is all these things that are new that were added. This was to access the object record and the various revisions stored in the server, and also the references that are cross-cutting references. I'm not going to speak about this any longer, but because I would like to talk about improving users' experience and how we improve security. In previous versions, user had a role in a KB, but inmate had serving another KB, permits. A role could have certain permits, and it was quite complex, all in all, to keep that system, because when you talked about a user, you didn't know what permits he had. So what we wanted to do was to redesign the security issues so that it looks similar to other types of securities that are familiar to us. To do that, we eliminated the role concept and we introduced the group concept. If you as a user belong to a group and you're a member of the group, of all the heads, as I said earlier, a user could have a role in a KB and another role in another KB. Now you're going to be the same user. Now groups, of course, may have different permits in different KBs. The other large change that we made is that users may have specific permissions in KBs. For instance, you can assign a role and work more easily there. That was one further step. And as I said earlier, this is easier to maintain and to model reality. I would like to say something about the dialogues of team development. We made some corrections there as well, minor ones. But in fact, this is quite useful because in many cases, they've told us that when you look for grids of objects, sometimes it was a restricting factor. It wasn't that easy in the update when you had a big AP to find a certain object. And so we thought that we should add new filters per type of object, per pattern, in the case of history, per user, and so on, without overburdening the interface in such a way that if you're not going to use it, then you can have more room for what you're interested in. Very well. The last improvement we made has to do with the update of objects. If you recall from previous versions, when you make an update of a group of objects, if one fails, the entire operation fails. So those objects come in that update and had been processed and saved correctly, all that would go back and you go back to the previous stage. Although in some cases this is necessary because perhaps if an object fails, has an impact on other objects that reference it, it's not something that you should always do. It's not always necessary. And the cost is quite high when, for example, you have 500 objects in a KB and it fails in the very last ones, the processing of the previous one. Well, you've wasted your time and you have to start once again. So as you can see on this snapshot, you have an example of how it used to be. You had lots of objects there. One failed, so the operation failed, and you have to start all over again. Now, in the new version, we added a new behavior of the update, and this allows us to avoid all this. So basically the way this works is that if an object fails in the update, GeneXus automatically will detect the other objects that depend on that failure. So you keep the integrity of the objects that have been updated. In this case, then, particular case that I'm showing you, what happened is that we had that procedure, and since it was not referenced, it didn't depend on it, they were updated correctly. And so it says that the partial update was successful in spite of a partial failure. So this may happen that an object fails but doesn't trigger the whole failure. In most cases, updates, even if they fail in some parts, they will move on. This is the end of the user interface and usability enhancements and improvements. And so now I'm going to refer to the improvements we made on existing operations in the server. Now, to explain the first improvement, when you ask an update to GeneXus server or any operation that requires the server to send an object to GeneXus, what GeneXus server does is to take the object from the knowledge base stored in the server. It makes a processing to share it in another format that can communicate with GeneXus, and it sends it. Now, processing is costly. It's costly, and it's something that is done even if you're asking for the same object in the same version, in different operations, different customers, but in fact it's the same. So what we've done in this version is to add a sort of cache that can persist and in that converted content for the communication in such a way that when you do it once for the first time, you don't have to have that cost of processing and use what's already been processed. There are some exceptions here, but in general terms, this significantly improves waiting times when you are making an update and so on. It also improves this considerably. Another improvement that we've made is related to the concurrent commit and updates. These were excluding mechanisms. If there was a progress, a commit in progress, you couldn't make updates, but we added support for unlimited commits and updates. And why have we done this? Well, what's happened is that when you were when we had a medium-size or large-size update team, it was difficult to go into a time window where you could make a commit because there was always someone asking or doing a read operation in the server, so you would get an error because there was an exclusion there. Now, with this change that we've made, it's not only that updates can always be served and the server will always be able to answer an update request, but all commits will be able to be carried out even if you're doing another operation. What you cannot do is to have more than one commit concurrently. Those were the most important improvements on existing operations. And now let me talk about the new features that we've added and their use. Well, when you are developing knowledge base, it would be ideal if you could focus on one certain problem, whatever the feature is. You would like to be focused on something and then move on to something else. But that's not reality. Many times you are changing an object and then you see that something is not right or it's untidy and you fix it. And then when you change this feature, you have an urgent request from a customer and so on. So in general, we are in a stage where we have modified objects and there are different requirements around. However, when you're going to have a commit, you have a requirement and you have something that is fixing something in particular. So what happens is that the task of making a commit and finding the objects is quite burdensome. And so in this case, I'm showing you this image, which I thought was quite similar to the problem we have. It's like the different post-its with different colors. You have different requirements and definition, and they're all mixed up. And if you had to put them together according to the color, you would have to go all over the wall to fix it. And so this is a snapshot of very few objects, but the idea is that you could read them, and that's why I didn't put 500 there, but these are quite a few anyway, and they're all in a disorderly manner. And so I'm developing a new feature in my KB. They have different patterns and so on and so forth. I would like to show you now how it would look like if we use changes. I grouped according to the transaction I was making. We have a change set, all the objects related to the transaction, that whenever I want to make a commit, I already know where I have to go. And for example, change set, feature, and so on. And you have to take into account that this is a very simple case. It's an unreal case, but I wanted to show it to you as an example. But it's now the question now that perhaps you're wondering about is, what if a single object has modifications, but these modifications are related to different requirements? And I can add it in the change set, and that's a very valid question. Now, the thing is that when you look at the commits, you would like to do them only regarding those changes, because those changes are related. And so, to do that, we decide a mechanism of partial commits. Basically, it allows you in a very simple manner to be able to exclude changes in my local objects when I'm making the commit, instead of having to do it by hand, to open it, save it, make the commit, and so on. So have a look at this snapshot of GeneXus. Here we have the comparison where you make the subset of the changes in an object, and we've got two differences there. In this case, the difference is just indicative. It's not a real case. But let's suppose that they correspond to two different subsets, and you want to save one of those changes to separate it. So how would you do it in GeneXus? Well, in the section where you find the difference, you would right-click, and you would be able to go line by line. And once you do it, it would be in red. It would be highlighted in red. This means that this change will not be included in the commit. I mean, in this particular case, we have added lines. These are new lines. You wouldn't have any. But if there were modified lines, you would have the lines on the screen on the left. And then in the simple line where it says order, I also made a change, and this was just to show you that that you can edit the comparison, and you can take this into account. The new feature I wanted to share with you is called blame. The idea is not that developers become angry and they break up. On the contrary, we have to add a new feature so that we can work in a team in a clear and simple manner. Well, the idea of this feature is that many times we are working with objects in your local KB, and you may come across a code version or a change that was not made by you, and you don't understand why it is there, or you would simply think that it's incorrect that it's there, and you would like to find an easy way, quick way to see who the author was of such a change. Basically, what we've been doing so far was that you had to go all along the record and commits and pray that you find the change in the commit that you're inspecting. Now, with this, you can see the content of the object and the commits making that change. In this case, we have the same pro as in the previous view, only that on the left-hand side, you have a table listing all revisions where each one of the lines were modified. You have the author, and if you hover over some of the lines, you have a little bit more of information. I mean, when and the comments are associated and so on. In this way, it's very easy to say who modified it, why, if there was an adequate comment to it, and when. You can continue working with previous versions and see how the object evolved. This is the end of the GeneXus server 15 release. This is what Gaston and Nicolas released yesterday. But I would like to share with you what we have thought of in the short term. New features that are very specific and that we think are quite useful. The first one is called update to revision. This means to update a specific revision. It allows you to have a set of objects and update them to a specific revision in the server, which does not necessarily have to be updated. This can be useful because many times you would like to see what the server KB used to be in the past. Perhaps there was a problem, and perhaps you want to set up that new version, or because you may be lagging behind in some objects and you can move forward in some. So in this case, this feature is useful. This is the GeneXus flow. As you can see on the right-hand side, there is a label where you have it by default. The latest is the present one.
Y elegir una revisión específica o una fecha.
And you can have a specific date in particular. If you combine this with the scope of objects and you say you want to have an update of certain objects, then you can do everything I was saying about bringing up certain objects and see how they were. The other thing we have planned for our first updates is to facilitate the work of integrations in the GeneXus, particularly when you are developing. As part of development, you want to create actions that are frequent. And so, in this particular case, we have an example where we have a KB. You can imagine that you have all those versions there, and you start releasing versions. As from the moment a version is released, you can make fixes to that release. So if a developer is working with this, he will have all the versions in the server. But the moment a new version is released, he will have no way of having that version in his KB, he will have to create another KB. So this idea is to allow for versions to be created afterwards, following certain restrictions. Now, in the previous case I was mentioning, it would be possible. So the flow would be like the one you have on the screen. You will have versions or the new releases you still don't have in your local KB. And so you will have to have a local version connected to the other one. This is the end of my presentation. I hope that you have found it interesting and that it pushes you to move on to the next version. Thank you.